Okay, so what we're going to do for this first one is we just have to decide what its skew is. So this thing I know is skewed left, because when we talk about the skew of a graph, or kind of how the graph goes, the skew of the graph always follows this tail over here. So this first one would be A, because the skew of the graph always follows the tail. The other thing that you get to know about that is the median is probably right here, but the mean will follow the skew. So the mean kind of pulls over. I don't know if it pulls over that much, but it will start to pull towards that skew. Let's look at the second one. So in this second one, it says you want to use numerical summaries to describe a distribution that's strongly skewed. What combinations of measure do you want? Well, let's just imagine we had something that was strongly skewed. I know the median, in yellow here, would be like right about here, because it's not affected by the outliers. It's always in the middle no matter what. The mean, because it has to add in the outliers, would probably pull it over. Well, this really isn't its center. Its center is really this median. So anything that has mean in it is definitely not going to be right, because the mean is pulled over. Now when we look at other things, the range will be a really bad measure of spread, because that outlier is going to make that data set really wide. So range would be a terrible measure of spread. Range is normally not a good measure of spread in general, so you generally don't use it. So then we have the standard deviation in the interquartile range. If you remember how you find the standard deviation, is you find the distance from all the numbers from the mean, add them together, and divide by how many numbers there are. Well, that means I would have to add in the outliers, which would make this one bad, which would mean that my median and my interquartile range would be the best. So if you have skew, the best ones to use would always be your median and your interquartile range, because your interquartile range is like set spots. They can't follow those outliers. Okay, let's try the next one. I would like to compare a person's height and how big their shoe size would be. What type of graph would allow me to see if these two data sets were correlated? Well, since we're not really comparing these data sets, we're looking at how they're connected. Anytime that you want to figure out whether something is connected, a scatter plot's a really good way of doing that, because what a scatter plot does is a scatter plot allows you to see how two data sets are connected. If I want to know which data set's better than the other one, that's where I'd use a box plot. And if I wanted to know like what percent of something happening, that's where I would use a pie graph. So pie graphs are your percentages, box plots are which one's better than the other one. Let's look at the next one. A professor records values for several variables for each student. These include the listed variables. Which one of these are categorical? So categorical is the type that you have no numbers. Quantitative, you have numbers. So the first one's bad. We have numbers. The second one, oh, that's categorical. It has no numbers. The third one has numbers. The fourth one has numbers, because it's the number of students that miss. So anything that is number-based is quantitative. Anything that is category-based is categorical. Let's look at this one. Oh, don't have that one up yet, so I'll put that one up. So it says, which residual plot shows the regression line is not a good fit for the data? So if you remember residuals, residuals are the distance away from the scatter plot line. So because it's the distance away from the scatter plot line, our hope would be our residual plot would look like something like this really close, like these things shouldn't be that far off the line, because you want your line to match up with your scatter plots, but obviously that doesn't always happen. Things that you don't want are patterns, because if you had a pattern, you probably could match your line to fit the pattern. So this is a narrow random band, we're good. Narrow random band, we're good. Oh, that has a U-shaped pattern. This is not the correct answer. Let's try the next one. Okay, so given this regression line, I need to make a prediction. So it says on the day where the temperature is 20, so I just have to figure out, is 20 my x value or my y? Well, they say call the temperature x, so that is my x value. So I'm just going to plug that in, so y equals negative 19 times 20 plus 1344. What I get is y equals, I have to do this on my calculator because I don't know what 19 times 20 is off the top of my head. And that's going to be negative, then plus 1344. So my answer would be 964, which is D. Success. Let's try the next one. Okay, there's a positive correlation between the size of a hospital and the median number of days the patient remains. Does this mean that you can shorten a hospital stay by choosing a smaller hospital? Well, a negative like the positive correlation kind of makes sense. Like the negative, it doesn't matter what the correlation is, right? Like you can always go the opposite. So that's not true. Yes, the data shows that it's shorter. Well, just because data shows that it's shorter doesn't mean that it's the reason, right? Like I can say during the summertime, or ice cream sales increase and so do shark attacks, but that doesn't mean that ice cream's causing shark attacks. That means that it's summertime. So that one is not true. No, the positive correlation, it can be explained by the fact that seriously ill people go to a larger hospital. Yes, that is the obvious answer. And then, yes, correlation can't just be an accident. No, like it can be. That's the accident. So if you want to go to, like if you go to a smaller hospital, it doesn't mean that you're going to stay for shorter. It really depends more on your illness than anything else. So make sure like you don't just believe that correlation is true. Like it has to be caused by something. Let's try the next one. Okay, so we have to tell whether this is a probability distribution. If you remember, the only two things we really care about with probability distribution is we don't have negative probabilities, because you can't have negative probabilities. Like I can't have less than a 0% chance of something happening. And then the second reason is I would know it's a probability distribution if it added up to 100. And so these top two are actually both kind of correct, but just because they have positive probabilities doesn't mean it's a probability distribution. It just helps. So I would say this first one, because they definitely all add up to 100%, and that's what you're really looking for. Probabilities can be decimals. That's silly. And then not impossible to tell whether, like the situation, no. Like we can tell. Like we don't have to be given a situation to tell if it's a probability distribution. The only two things we need is them all to be 100% and them all to be positive. The 100% trumps everything though, because that's a harder condition to fulfill than just being positive. Let's try the next one. Okay, which is the discrete event. Discrete events are things that are countable, so like things I can count on my hands. So that's what a discrete means. The weight of a newborn baby. I can't count that on my hand because that could be like 18 point whatever pounds. Like I don't have a part of a finger. Temperature of my coffee. No, because again, like you can have a partial temperature. It doesn't mean that I have to have like 97 degrees. It could be 97.3 degrees. Can't count that on my fingers. Number of students in the stats class on a given day. Yes. I can't have half a student. So this has to be a countable number. I can go through and count on my fingers how many stats students we have. I just might have to restart a couple times because we normally have about 20. So that is the correct one. Height of a newborn giraffe, again, it could be a decimal. So anything that you have to measure with like a measuring stick or a scale or a thermometer or any measuring device is a continuous thing. Anything that is countable is a discrete. Let's try the next one. We need to find the expected value. So expected value is that EX formula, which is the sum of the X sub i's times the P sub i's. Or an easier way of saying this is multiply all these things and add them up. So 1 times 0.4 is just 0.4 plus 2 times 0.3 is 0.6, plus 3 times 0.3 is 0.9. So 0.4, that's a terrible 6. 0.4 plus 0.6 plus 0.9 would give us a total of 1.9, and that would be my final answer. Make sure that if you didn't get 100% on this, which is probably why you're watching this video, that you're kind of going through making sure that you know how to do each problem so that you do well in the final.